Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on October 8, 2025, just yesterday. This paper introduces a continuous visual tokenizer that unifies image understanding, generation, and editing in one autoregressive model, delivering more than 3.5 times faster text-to-image generation. The paper is titled Ming-UniVision, Joint Image Understanding and Generation with a Unified Continuous Tokenizer. And, as we'll see later, the implications for model efficiency are quite significant. In short, a three-stage tokenizer feeds a single large language model, enabling multi-round in context workflows and state-of-the-art image generation while staying competitive on multimodal understanding. Also, the authors shared a GitHub repo. You'll find install scripts and requirements, Docker setup, and runnable examples for both MingTok Vision and Ming-UniVision. There's a reconstruction demo, unified inference via the Ming-UniVision infer class, multi-round editing workflows, and VLLM integration. Model weights are referenced, with example prompts and end-to-end usage to get started. You will find UniVision 16BA3B with 18.88 billion weights, generate and edit examples, and MingTok Vision with 698 million weights from pre-trained usage and forward ENC deck reconstruction. Alright. Figure 1 shows what the unified continuous tokenizer delivers in practice: strong image generation, editability, and faster training in one system. The top panels highlight diverse generations, which signals rich semantics and texture control. The middle row demonstrates prompt-guided edits across faces and scenes. The strip below illustrates multi-round in-context editing that compounds changes step by step. On the right, the Genival score plot indicates over 3 times faster convergence versus an SDVAE baseline. So, Figure 2 shows the three-stage architecture that makes continuous visual tokens work end-to-end. The low-level encoder compresses image patches into compact, continuous latents that are friendly for generation. The semantic decoder expands those latents with causal attention, which means each token only looks left, so sequences can be predicted naturally. Training uses masked feature prediction, a hide-and-recover game that teaches semantic structure, plus pixel reconstruction. Bidirectional attention stabilizes the encoder and the final pixel decoder for faithful reconstructions. So, Figure 2 showed the three-stage flow. Table 1 now spells out the core hyperparameters that make it run efficiently. It fixes the input resolution at 512, which standardizes training and evaluation. The encoder and semantic decoder use patch size 32, so the sequence stays compact. The pixel decoder switches to patch size 16 to sharpen textures. Attention types differ, with causal attention only in the semantic decoder so tokens can be predicted in order. Alright, Figure 3 shows a single large language model that handles understanding, generation, and multi-round editing through one continuous visual interface. The model keeps a unified next token prediction loop where text tokens and continuous image latents interleave so language and visuals evolve together. A per-token vision head predicts compact latents, which the semantic decoder immediately expands into high-level features. Rectified flow trains this head to predict a clean direction of change, so learning and inference proceed faster. Figure 3 showed how one loop drives understanding and generation. Table 2 now measures how well that design understands images across many benchmarks. The table compares models head-to-head, so it highlights where the unified continuous representation helps and where it struggles. Ming-UniVision 16BA3B ranks competitively on MMStar, Illusion Bench, AI2D, and MMVet, with MMVet around 64. The model lags on OCR Bench and MMMU because character-level details are hard to preserve in a compact latent space with a causal semantic decoder. Overall, the shared semantic tokens remain expressive for broad vision language understanding. So, Table 3 reports how well models turn text prompts into faithful images across several skills. The key takeaway is that the unified continuous approach leads the overall Genival score. Ming-UniVision reaches an overall about 0.85. It scores about 0.92 on position relations. Colors land near 0.93, while color attribute tracks around 0.70, and DPG bench comes in near 82. Wrapping up, 2 takeaways stand out. A continuous visual tokenizer reconciles generation and understanding in one next token loop, and it delivers faster training with strong text-to-image fidelity while staying competitive on broad vision language tasks. The broader implication is simpler, unified multimodal systems that support fluid, multi-round editing. That is it for the AI Research Roundup. I am Alex. Thanks for listening.